So my dear students, today we are going to talk about the final part of the second lesson. The topic comes as coping with changes. So you know that normally even in a human lifestyle we need changes, right? We do changes and we do modifications for our lives, right? So in the same manner, softwares also need their changes and their improvements, right? So we call them the changes of the software, right? So the question arises, why a software need change, right? So I have come up with some reasons why is a software need a change. The first point gives us when the business change. Now you know that when the business are changing, the business environment is changing, you have to modify your software, right? So it's pretty clear. And when there are new technologies available for you, so you have to upgrade your system to get the benefit of the new technologies, right? So maybe your older software or your legacy software maybe not be able to function with the new technologies, right? So you have to upgrade your software in order to add the new technologies and new features for your system. And then comes the changes of platforms. You know that now, if you can remember, before the year 2008, smartphones were not much popular, right? So, but now in the year 2020, smartphones are very much popular and it has become a must for a user, right? Now, in that era, it was like a one smartphone for a company. Then it came for a one smartphone for a family. Now, then it came a one smartphone for a person. And now we are moving to an era where there are 2 or 3 smartphones for one person, right? So, when the platforms are changing, now in the era before 2008, developers were worried only about developing a software for a laptop or a desktop computer. But now the developers should consider desktop computers, laptop computers, as well as smartphones, smart devices, kiosks, and new technologies and new operating systems, right? New hardware, right? They have to think about all that platforms which are changing. A customer may be able to reach you from any other platform. So you have to make sure your system is available for any other platform. And then problems with existing systems, right? So it's pretty clear when you're having a problem with your legacy system or the previous system, you have to modify them, right? You have to upgrade it to overcome those errors. And increase of competition. Now you see, there are many number of supermarkets and they're having a big competition within them, right? So to get the competitive advantage, they are always giving new services to their customers, right? For example, they may have home delivery service, they may be using online card payments and online ordering, and such services are rendered to their customers, right? So they can give a good competition to their competitors, right? They can get the competitive advantage through improving their systems, right? And the other thing is effective use of information, which means that now you know there are different sciences, right? Data sciences, data mining, data warehousing, data cleaning, data processing, and AI tools, machine learning. There are many different data science tools, right? So to get the benefit of it, you have to upgrade your system to the information may be the same information you get in your daily transactions, but with a highly functional data analysis system, you can get more effective use of your information than the legacy system. And when the organization grows, you have to improve your system. Now, let's say if you're having a customer base of 50, this is certain you can manage it from a laptop or a computer. But let's say you're having a customer base of 5,000 or 50,000 or 500,000, then you have to improve your software, right? You have to improve your security. You have to improve your database capacity. You have to improve your servers, right? So when your organization grows, with the customer base grows, now then you have to change the software into a better level, right? And also, when the government or the business people, then they give you new laws and regulations, right? You have to actually change your software, right? Now, an example is that in the past there were advertisements without the price, right? Now, in a recent year, there was a law, as a regulation. You should tell the price of your product during the advertisement, as well as when you're publishing an advertisement on maybe newspaper or website or whatever, you should give the price of your product. It should be a must. So the businessmen, e-commerce people, they had to change their websites according to the new regulations as to show the price tags of their products. So now you have an idea why a software need change with time, right? So when an organization calls for a change of their software, they have to make an excess payment for the change of the software. For example, if it's a cash system, they may want a card system or an online transaction system, and then they have to put some cost for the development of that particular module, right? So that cost which is taken for unnecessary modifications and changes are called overheads, right? Now let's take a real life example. Imagine when you are going for a trip, you may take 5,000 with you for the use within the course. But by experience, you know that if you plan for 5,000, you may end up with spending more than 5,000, maybe 7,500 or maybe 10,000, double the relevant price you were planning to. So those are called overhead costs. In computing, in computer science, overhead is a combination of excess use of resources, right? You may allocate your resources for a certain development, but by the changes and the modifications, you may have to use your resources excess to the level you planned. Those are called overhead cost in computing. So it's very important to avoid changes as much as possible, because when you're asked to change the software, it's difficult and it will make a huge cost on you, right? So it's important to avoid much of the software changes as possible. So the question, how to avoid so much of software change, right? Are there any methods or standard ways or practices by developers to avoid much changes, right? Now there are a few. First thing in your syllabus is to talk to you about is that first to change the anticipation of the owner, right? Now what do you mean by changing the anticipation, right? Now let's take an example. Maybe your customer may say they have their own business, and they may say they want a cash flow system and a cash based system in the initial requirement specification, right? So they may say we want this cash system. But as a developer or development team, you know that the user may one day come up with a modification to have the card payment system or an e-commerce mobile system, right? So one thing you can do to avoid much change is to let your customer aware of new technologies. Now in the initial requirement specification, you go to the customer and say, sir or madam, now yes, you told us that you want a cash system, but now the trend is this, and there are new technologies as such, and customers are using, there's a potential here, you can access this much of customers, and you discuss with your system owner, and you can let them aware of the new technologies, and they may say, yes, okay. Because the system owners may not be Full computer literate persons, they may not have much experience in the IT industry. So, as people who has experience in the IT industry, you can introduce them the new technologies. Okay. So then the customer may say, okay, we'll have this, right? So you avoided the change in the future by letting your customer aware of it, the previous stage, right? And the other thing is providing prototypes. Now, what are prototypes? Prototypes means that proto means previous. Now, let's say you want to introduce them a new system. So let's say you want to introduce them a QR code system or a barcode read system, right? So so your customer, your client, may not be aware of what is a QR system or a barcode system. You may introduce them through a whiteboard or a presentation, but they may not understand it well enough because they don't have a hands-on experience, right? So what you can do is you can create a dummy setup or a dummy software, which is not the correct one, a dummy setup, and you can show it to your customer and actually tell them to experience the situation, right? To get the QR codes, to scan the QR code, and to test the system, not actually testing, actually the field, to get the experience before the system is developed. So by providing dummy setups as such, you can tell your customers about what they are going to get at the end and also what they can also gain from the new technologies around, right? So you can let them know about the new technologies and new trends and the pitfalls by providing them prototypes, right? And there are, now when you're using a software, there are trial versions, right? Which are not the real version, but you may get trial versions. Now, you may have gone through many trial versions of different softwares, right? So by using a trial version or maybe a software license for a 30-day or 10-day or 3-day, likewise, so you feel the software, you get the benefit of it for a certain time and you get the taste of it, right? Then you can get the decision whether to use it or not, right? So in that manner, developers will be able to tell the software owners about the new technology and avoid changes in the future. I can tell you a real life example. Now, when we were in school, Facebook was not much popular, but it was popular among children by that time, right? And teachers were very against it, right? So, as students, we tried many times to impress our teachers to use the Facebook platform, but they didn't like it because we were using the previous method. We call let the customers aware of the new technology, but it was not enough because the customer didn't feel this setup, so customer was not liking the thing. So what we did was we came up smartphone and showed the teacher, and we gave the smartphone to her hand and made her feel and experience the use of Facebook. How you can send messages, you can see posts, you can see messages, and see photographs, videos, and so on, right? And then the dear teacher got the idea of what is Facebook and how to use it correctly, what are friends, and how to get the benefit of Facebook using it correctly, right? Thereafter, after a few months' time, she made her Facebook profile and she came to the Facebook. So it's a good example why it's very important to show the customer as well as to make them feel, make the experience of the setup before using it. So then the customer will accept the new technology in their software development. So it will be easy for the development team because then there will be less changes in the future because you have made the system to a future state, right? Your customer, the client may ask You need to develop a system for the present, but you are developing the system thinking about the future of the industry. So then you can avoid much changes. Okay. So in your syllabus, it's important for you to understand what are the benefits of using this prototype system, right? So I have listed some benefits here. First thing is improved usability of the system, right? So how can the usability of the system increases when you are providing a prototype, right? Now the stats says that when you are having 100 features in your system, 80% of the software functionalities are not being used by users, and only 20% of the functions are used by system. That means that if you make a system with 100 features, only 20 features will be useful for your customer, and other 80 features which you are developing will not be used by your customer. So then all the 80% of the software functionalities which were not used by the customer is a waste, right? They may have paid for it and you developed it. Customer may not get the usability of all your hard-coded features. So these wastes happen because you don't know how the customer will use the software, right? So when you are providing a prototype and when you are asking the customer to use it, you can look into the way they use the software and you can avoid unnecessary functionalities which you are about to provide, right? You may talk to them that you are not using this functionality. So this is waste of resources and cost, and you can cut off it from the requirements definition, right? So by giving a prototype, you can clearly understand what the customer really wants, right? In software development, there's a famous quote saying, I can't remember by whom, but there's a famous quote saying, it's not about how much of functionalities you provide with the software. It's all about how much of functionalities they don't want to take off. So if almost every functionality in your system is useful to them, if they don't want to take it off, then your system is very useful to them. So you can say now the usability of the software is being improved, right? So by providing a prototype and getting the real user requirement will make the system more usable, right? So the second point also say a similar thing to that, a closer match to the user's real needs. You can get the real need of your user, right? So they may be tell something else, but the real need, you have to understand the real need, real business need, right? And by providing a prototype, you can get what they really want. They may not be able to express it correctly in your IT-related terms, okay? So it also improves the design quality, improves the maintainability, right? When you're having less and highly functional functionalities, it's easy to maintain the system because you have less functions and they are very useful, and it's easy to maintain because it's not the complex system and you exactly know what the customer wants. So it's easy to maintain, okay? And because of that, it reduces development effort, and it's beneficial to both parties, the developer and the client, because the developer don't have to develop unnecessary functions, and also the client will don't have to pay to functions they may not using in the future. So the next point says the requirement engineering process. Prototypes can help with the elicitation and validation of system requirements, the same thing. And the last point is, in the system design process, a prototype can be used to explore software solutions and in the development of the user interfaces for the system. Now, there's a point you have to understand, user interface. User interface is the main heart of the program because that is the main thing the user interacts with, and that is the main thing the user get any output. Okay, so the interface is very important. So when you're making the user interfaces, it's important you to show them prototypes and get their approval, and maybe you may show them a prototype of a similar system, and you may ask them, is this what you want? So then they may say, no, I don't want this. I want this button in this size, this button in this side, and this text I want here, and I want this information in here, I want this calculation in here. Likewise, they may explain the interface once you provide them a prototype. So if you don't provide them a prototype, they won't be able to explain you or to give a feedback on how they want their interfaces. So by providing a prototype, you can get their feedback and improve the usability of software by giving them their software which they really need. Okay, so we'll move on to a past paper question. Here the question says, what is the most suitable process models among following to build a flight control system in a modern aircraft? Right. So I know that extreme programming, rapid application development, and Scrum are related to agile development models. Right. Now, we were discussing in the initial videos that agile systems, agile development models are used when the requirements are not clear, right? But when you are developing a critical system such as a flight control system for a modern aircraft, you can do testing as in a normal accounting software, right? So you can't send flights into the air and check, right? You have to be very clear with the requirements at the initial point, and you have to build the aircraft. You can't change it once it's done. So my first answer is answer D as a waterfall model, and then my answer is prototyping, right? Because waterfall model means that you get the initial requirements at the beginning and you develop the system by the end. So no turnbacks during the development process. And why is prototyping important here? Prototypes are important because when you can actually change the whole aircraft once it's done. So it's very important to show the air clients or the aircraft engineers what they are be getting at the end, right? So you can't change once it's done. So it's very important to provide prototypes, right? Dummy setups, and to get their approvals step by step, and finally to develop the aircraft control system. And my other thing is that why agile methods are not reliable here. So my answer is, now agile system is for when the requirements are not clear and you are developing it by versions. But let's say if you are making a flight control system, you can't have any change, right? You can't have versions, right? A simple mistake can cause a huge impact, right? A flight may crash, a flight may lose, right? And there's a huge impact. So you can't play with that. So you have to be very clear with the requirements and you have to completely do the system. It's same as doing a life support system in a hospital, right? You can't have versions. You can have better versions, or you can't improve, or you can not give it by versions, right? You can't give a patient, now this is the version 1, now you have better life support version. No. If the previous version failed, the patient will die, right? So it's very important to have all the requirements clearly and build the system, right? So it will cost a lot for the development, but it's not suitable to develop such a critical system with an agile process. Okay, so I think I have a good idea about that now, and we are moving to another question. Which of the following process model is most suitable for requirement refinement refinement, right? You can get the meaning of the word refinement from dictionary. It means simply you to check, to validate the requirements with the customer, right? So the best thing is to to get the customer's validation, it's better to provide them prototypes, dummy setups, right? Dummy softwares, dummy setups, dummy images. Likewise, you can show them and get the approvals. Okay. So after that, and there's another thing you have to consider to avoid much software changes. The second point is, first one is change anticipation, that is before the development, and during the development, that is to change tolerance, right? You are going to develop the software tolerant to the change. Now here, I have a school system with student model, teacher module, parent module. Okay. So these three modules are interconnected and they have functions in common. Now there's a login for teachers, login for student, and login for parent, but the login module is common, right? And check homework functionality is also common. Get results, log out, everything is common to teacher, student, and the parent modules. And there are also some unique functions for student, teacher, and parent, right? Now, a disadvantage of this thing is that imagine a problem comes as a teacher cannot log into a system, right? So then they have to close down the login module and to check the code. So during the modifications or when you are repairing the login module, a student or a parent may not be able to log into the system because login module is common to all parents and students and teachers. So none of them can log into the system because the login module is common, right? So this kind of a system we call is as highly coupled, right? They are very tightly coupled with modules and they have common modules, right? We call it highly coupled, right? And I have another image here. Now here you can see the same system, parent, teacher, and the student, but the modules are very independent, loosely coupled, not highly coupled, loosely coupled. Teachers have their teachers login, two students have their student login, parents have their parental login, right? So if an issue arises in the teacher's login, the student login and the parents login will not get affected, right? Because they are loosely coupled, they have their own login modules. So that we call is cohesiveness, having their own system for own modules, right? So that kind of a modularity is called highly cohesive, right? Cohesive modules means that they have their own functionalities within them, right? They don't depend on other modules. So that is called highly cohesive. They can do their own work, right? That's highly cohesive and loosely coupled. Okay. So the topic goes as how to avoid so much change. So by coupling loosely and having a highly cohesive modules, how can it help the development team to tolerate changes? Yes, now you are clear that now in a highly coupled and low cohesive system, once a modification arises, they have to change all the modules because the functionalities are common, right? Because they are highly coupled and their data is interchanged between different modules, and the different modules don't have their own functionalities. So when you are going to change it, it will make much hassle. Imagine, for real life example, imagine if 3 employees are being given one laptop, right? And if one of the employee take it home or make any damage, the other 2 employees are also get into trouble because they can't do their work. But if you provide all three employees with one laptop each, so that kind of a problem will not happen, right? If you ask to change someone's laptop, let's say person A, and the person B and C won't get affected, right? But if they have a common laptop, if one change is done, it will affect all the employees working from that laptop. So likewise, when you are developing modules in a loosely coupled and highly cohesive way, then it's easy to make the changes and modifications for the development team. Now here is a past paper question that says, which of the following is correct? Complexity of a program depends on its modularity, and modularity facilitates maintainability. Now, complexity of a program depends on its modularity. Yes, that's correct. Because modularity means you are breaking your software into modules, right? If you find many modules in your system, it's a complex system. If you find few modules, it's a simple system, right? So complexity of the software or the program depends on its modularity. Okay. Modularity facilitates maintainability. By the example which we are talking before, you know that when you make the system with modules, if you couple them loosely, it will facilitate maintainability. It's easy to maintain because it's developed by modules, and when you are changing a certain module, it won't affect other modules. Okay. And C, it says encapsulation allows several objects in a class hierarchy to have different methods with the same name. Now you know that there's polymorphism, and that comes in a lesson up to come. And cohesion should be minimized to make the modules independent as possible. No, cohesion should be high. When the cohesion is high, a module can run on their own. They have their own methods, right? So when the cohesion is high, modules are very independent. So D is incorrect because it says cohesion should be minimized. No, right? And E, a system model based on shared database is called a repository model. Yes. Okay, you can Google and see what's a repository model and get the diagrams of a repository model. And here's another question. Which of the following is true? A, loose coupling means component changes are likely to affect other components. When you are coupled loosely, now if you get into that diagram, if you couple loosely, it won't affect other components, right? So when you are having a highly coupled system, it will affect other modules, right? So when you are coupling loosely, it won't affect other components. And B, modularity helps to reduce complexity. Yes, when you develop the systems into modules, it will be easy for you, right? Modularity means you get the whole system and break it down into modules. Okay, and cohesion should be minimized. No, cohesion should be high. Modularity increases the complexity of the project management. No. When you're having modules, and when you make modules and break down the system, it will be easy for you, right? Modularity will not increase the complexity of project management, right? And loosely coupled modules facilitate code reusability. Yes. Now, what is reusability? We were talking about the reusability in the second video. And when they are loosely coupled, right, you can get the module and use it even in another software because it does not depend on any other module. So therefore, you can take it or make it a copy and apply it into another system even, right? Because it doesn't depend on other. modules. By the example which I was talking before, if you have an employee with a laptop for his own, you can just move him to another office because he has his own laptop. You can move him. But when it's highly coupled, when the 3 employees are having one laptop, you can't move an employee to another office because his documents and everything is in a common laptop, right? You can't reuse it, right? But when the coupling is loosely done, then you can take it out or use it in another system easily. And another question here, relate the software process model in column X with the statements given in the column Y, right? Okay, so you can get the answers here. Answer is B. 1. RAD, Rapid Application Development, is suitable for a library management system to be developed within 3 months, right? You have to develop it quickly, right? So a rapid application development, agile system will be okay, right? So because giving it by versions will not make any impact. And for second one, prototyping, connected with D, a pilot training simulator for Sri Lanka Air Force, right? Yes, prototyping, you can do it, right? You can provide some prototypes and give the Sri Lankan Air Force and ask, is it what you want, right? It's very important to provide the prototypes before development, because once you develop the system, you can't change the aircraft or the simulating system, okay? And 3 goes with A, waterfall model, a system for issue tickets in Sri Lanka Railways. Yes, that is because now ticketing a system, you don't have to go for an agile process because you know the requirement. So quickly you can get the requirement and easily you can identify them. So you can develop it by the waterfall model. And fourth one goes with the incremental development, goes with the answer C. Incremental development means that you develop the system in kind of iterations, right? And online shopping system which starts with basic features and moves on to more advanced features later. So that is increasing, right? You first deliver something and you increase it, you increase it, you increase it, you increase it, and you increase the whole system into a good functioning system with the development of the shopping system, right? So for the incremental development model, you can watch the second video. And now we have come to the final part of the lesson, the process improvement. So this part is not something related with client. This part is about you or the development company. So we are going to talk about how to improve the development company or the development team, right? So that is called the overall process improvement. So process improvement means understanding the existing process and changing these processes to increase quality, reduce cost, and reduce the development time. So these are the 3 main targets of a company: to improve their quality, reduce their cost, and reduce the development time. So talking about the process improvement approaches, there are 2 approaches for process improvement. One is process maturity approach and the other one is agile approach. So we are going to talk about agile process in the latter part of this subject. So I'm going to talk about the process maturity approach. You have to mature your process, right? Getting mature means you're getting your experience and you're improving yourself, right? So process maturity approach, that means improving the process and project management by introducing good software engineering practices, which means that you develop your development organization by adding and introducing good software engineering practices. Okay. And the primary goal of this approach are improved product quality and process predictability, which means that by introducing good software engineering methods and principles, you can improve your product quality and you can have more confidence on your development. That is why it's called the process predictability is increased. Okay. And this is process improvement cycle. This is simple cycle you can understand easily. I'll get into an example by a school. Now, how the school improve their process. The main process of a school is to educate their children. And first thing they do is they measure. They give you test, term test, examinations, right? So they measure. After that, they analyze your results, right? After analyzing, they make the necessary changes so they can improve, right? Again, they measure and they again analyze the result and they make the changes. So likewise, that's a process improvement cycle. Okay. Now in your school, they analyze or they measure your marks, right? Your marks for mathematics, your marks for English, marks for science, likewise. But in software development, their measurements are different from that. They measure time, right? They measure resources. They measure number of occurrences, mean that defects, bugs. Those are few examples of the measurements they do in a software development company, right? So, for example, they may get a project, so they measure the time they get for the development, and they analyze it, why they got that much of time, and they make the necessary changes by the good engineering principles. And then again, they measure the time, whether it had been improved or not, and then again they analyze it, and they find their faults, and they change. Likewise, they measure the resources they used, then they measure the number of bugs they come up with. Likewise, they measure it and they analyze it, and then they find what are their shortcomings, and they change them to a better level, and they measure it again, and again they analyze it with the new system and go for a new change. Likewise, it's a cycle, right? So now we are coming to a very important part of this video, the capability maturity model, CMM. So it was given from the Software Engineering Institute, SIE, and this is a model which was given for development organizations, especially for project-driven organizations, maybe IT projects, engineering projects, or whatever, right? So they give a level for the organization by their activities. Okay, there can be level 1 organizations, there can be level 2 organizations, level 3, 4, and 5 organizations, and they have found that 80% of the organizations are in level 1, level 2, or level 3, and the other kind of 18% in level 4, and maybe 2% in level 5. So we look into that in more detail. The level 1 organization, we call it an initial level organization. Now, how to identify an initial level organization? Now, their processes are unpredictable, right? They don't have a plan. They don't have a control, right? They are poorly controlled and reactive. They are doing the same thing again and again, right? And they don't have proper ways of doing. They do it as they like, right? So that is called reactive. They have no proper way to do it, so they reactive to every situation that comes, right? So that type of a company is called initial level company. Very poor, okay? And then comes the second level or level 2 companies. They are managed. They manage their products, right? Now, a level 2 company means that they have the organizational policies, right? they have a proper documentation, right? They have a documented plans, right? Project plans, they define project goals. They have goals, right? And they manage their resources, right? So wastage is less. So process monitoring is there, right? So that type of an organization is called a manage. They manage their product. And then comes level 3, right? Hard to reach level 3. They are called defined companies. Actually, they manage the process, right? Now, if I take an example as an institute, if a managed institute, they manage their students, right? If an institute is in level 3, they manage the education, the process, the learning process, right? The teaching process. So a level 3 organization is running by process management, right? They have organizational standards, right? They are looking for international level productivity, right? They have standards. Standards means that why do we need standards? We need standards because to make our products reputed, right? So a defined company means they have their standards. Now, even in Sri Lanka, we can see some organizations post their standards. We are in this standard. We have this standard. We have this award. Likewise. And standard deployment of process, tools and procedures, right? They use their tools and processes and procedures are in standard deployment. And each project has managed process that is adapted to project requirements from defined set of organizational process. Since they have their organizational standards, every project is run organizationally defined process, right? They have their process and they have their standards. They work it out, right? This is level 3. And then comes the level 4, which is very hard to reach. Quantitatively managed, right? So this type of organization, they manage their quality, right? They have managed their product, they have managed their process. Now they are looking to manage their quality, right? So organizations use statistical and other qualitative methods to control sub processes. They use stats, right? They don't say it's good, nice. No, 90% good, 100% good, it's 200% good, like that. They have stats, they have numerical units, and they have targets, right? They have productivity percentages. They often look for their efficiency, right? They go for a statistical analysis, right? So in that way, they maintain their quality. So when an organization reaches that level, people will say, now if you give our project to this company, they will definitely make it good. Because the clients know that these companies are maintaining their quality. And then the 2% of the world will be able to reach level 5. That means they are the pioneers of the world. They are optimizing level, right? They are improving the process. Now, in the level 3, they were managing the process. But here, they are improving the process, right? They are not going to look into any engineering standards. They have done everything. Now, they are making new engineering standards. They have all the qualitative management and product management, process management, everything is done perfectly. And their next goal is to optimize their processes. That means to find new ways and innovative technological improvements to make their performance better, right? All the companies below them are looking into them, right? They are looking into their ways. Those sort of companies are in the level 5 of optimizing, right? So organizations must use the process and product measurements to drive process improvement. They're improving their process innovatively. They're making new engineering principles, right? Trends must be analyzed and the process adapted to changing business needs, right? They change the world. They make the trends, right? So they come up with new technology, right? Now, when I'm telling these things, what are the companies in this optimizing level, right? And innovative and technological improvements are performed, right? So, finally, I would like to make it a point to tell you something to follow this capability maturity model to your life. Initially, when you're starting, right, your processes are unpredictable. You have no control over your life, right? And you react to everything outside your world, right? That is the initial level of a student, right? Now, after that, you come into a managed level. You have your policies, you have your personality, right? You manage your resources, right? And you monitor your resources. You have responsibility about yourself. That is the level 2, a managed student. And level 3 is that a process management, the defined student. That means the student has his standards. He has his standards, right? He has his discipline, right? He knows how to behave, right? Wherever he goes, he behaves in according to his standards, right? And a level 4 student, quantitatively managed student, will go for according to his plans. He has his plans. He do his work planning before starting of anything, right? So in that way, he can quantitatively manage himself. He look into his watch and how much time I have spent on this, how much time I have spent on this, how much time I should rest, how much time I should read, how much time I should serve, likewise. And he quantitatively manage himself. And it's not easy to be a level 5 student, which is optimizing student, but outstanding student who used to maintain and improve his own life. He takes responsibility for his life and he improves his own self without the support of parents, teachers, or any other person. He improves his own self or she improves her own self. So that is an optimizing student. So I invite you to be an optimizing student. Thank you very much, students. I am Sandaruwan Fonseka. These are the resources I've used for the presentation. Hope you gain much out of this. So thank you again and wish you good luck.